Australopithecus sediba. It was a strange creature. No one had ever seen anything like this. It had a very derived face, advanced dentition, somewhat like a human's, a very small brain, ape-like arms.
What do you mean a derived face?
Welcome to Eyewitness Headquarters. Every story has a witness.
Before we begin, I need you to hold a number in your mind. 1,977,000. That is not a year. That is not a distance. That is an age in years of a skeleton that will become the center of everything we're about to investigate together. Now hold a second number. 9, that is the age of the boy who found it. Somewhere in the gap between those two numbers, between 9 and 1.977 million, lives the most extraordinary detective story in the history of human science. And I want to be clear with you from the very beginning. This is not a story with clean answers. Some of the central mysteries we will investigate today remain genuinely, frustratingly, beautifully unresolved. That is not a failure of the science. That is the science working exactly as it should. Here's the first question I want you to carry with you, and I will not answer it until the final hour of this investigation. Was the thing Matthew Berger found actually our ancestor, or did it die so that we could live? Those are not the same question, and the difference between them may be the most important thing paleoanthropology has argued about in the last 50 years. Let's go to South Africa. Let's go to 2008, and let's begin. But before we go any further, a quick word. If you are the kind of person who found their way to a video about a 9-year-old boy, a 2-million-year-old fossil, and the most contested question in human science, then you are exactly the kind of person this channel exists for. We make documentaries about the moments history almost forgot, the discoveries that changed everything. So the stories that the textbooks summarize in one paragraph and the internet reduces to a headline. If that sounds like your kind of place, hit subscribe right now. It is completely free, and it means the next time we uncover something like this, you will be the first to know. Now, let's go find this fossil. Picture this. You are standing at the edge of the Cradle of Humankind, a UNESCO World Heritage Site, northwest of Johannesburg. The grassland is dry and golden. The sky is enormous. The sun is merciless. Close your eyes for a second. You can almost hear it. 2 million years of silence pressing down on everything. This land had already given us some of the most significant fossils in human history. The skull of Mrs. Pless, an Australopithecus africanus, found in 1947. The skeleton of Littlefoot, painstakingly pulled from the Sterkfontein cave over decades. The Cradle of Humankind was the most intensively studied paleoanthropological landscape on Earth. And that is exactly why almost everyone had agreed. There was nothing left to find. But here's the first question I want you to sit with. And I mean, really sit with it. How do you find something that everyone has already agreed isn't there? The scientific consensus in 2008 was this: The major cave systems had been mapped, surveyed on foot, by vehicle, by hand. Generations of scientists, generations of boots on that exact same ground. The idea that a significant new hominin site was sitting undiscovered in this landscape was considered somewhere between unlikely and absurd. Enter Dr. Lee Berger. Now, I need you to understand who Lee Berger was in 2008, because the popular version of this story always shows you the triumphant scientist holding the fossil. It doesn't show you the man who existed before the fossil. And that man is the whole story. Lee Berger, American-born, raised in Georgia, shaped by an Eagle Scout's conviction that the world rewards those who go looking. He had built a respected career at the University of the Witwatersrand in Johannesburg. He was charismatic. He was media savvy in a field that historically distrusted media savvy scientists. And by 2008, he was running out of time. Not literally, not medically, but professionally. That particular kind of running out of time that academics understand deeply and almost never speak about out loud. He hadn't made a major discovery in years. And the field, and quietly behind closed doors, had begun to view him less as a frontier scientist and more as a promoter, a communicator, someone very good at talking about paleoanthropology. There's a particular cruelty in that distinction. I want you to feel it because it matters to everything that comes next. Lee Berger knew what people were saying, and sometime in 2007, he made a decision, either the act of a visionary or the desperate gamble of a man with nothing left to lose. He opened Google Earth. Stop. Because this is where the first layer of mystery deepens. The technique sounds almost laughably simple in retrospect. Using satellite imagery to scan for geological depressions, cave collapses, features in the terrain that might indicate cave systems below. Cave systems that had never been physically investigated. Berger and his colleague, Dr. Job Kibi, spent months doing this, essentially doing archaeology from space. The result? They identified more than 600 previously unrecorded cave sites in the Cradle of Humankind. 600 in a landscape the scientific community had declared essentially exhausted.
By my explorers who had gone down into a tiny crevice, the most amazing, risky thing probably anyone's done for this science, had gone down into a 7-inch slot, 30 meters underground, after traveling through this tortuous cavern to get there. And there they saw some fossils lying on the surface. They did not have a camera.
And I need you to keep a second question in the back of your mind. I will answer it, but not yet. Why did it take satellite technology to find what human eyes had missed for 100 years? What were people looking for that made them blind to what was actually there? The answer to that question tells us something profound, not just about archaeology, about the nature of assumption itself. August 15th, 2008, the Malapa site, one of those 600 newly identified locations. A collapsed cave system in ancient dolomite rock. Lee Berger had obtained the necessary excavation permits from the South African Heritage Resources Agency. He had driven out with a small team, and he had brought his 9-year-old son, Matthew. Now, this is where the popular version of events loves to lean into serendipity, the lucky accident, the child wandering off while the adults do the real work. But I want to investigate this framing carefully, because it conceals something important. Matthew Berger was not an ignorant bystander. He was the son of a paleoanthropologist. He had been raised essentially in the field. By age 9, he had been on more fossil surveys than most graduate students. His father had taught him, as part of a family apprenticeship, what to look for: the shape of a bone, the curve of ancient cortical surface against the flat fracture of ordinary rock, the specific way that fossilized biological material catches light differently than the surrounding stone. Matthew Berger had been educated to see. And yet, and this is the crucial thing, what Matthew found that day, he found by accident, or did he? Here is mystery number 2, and it is more philosophically complex than it first appears. Is there such a thing as a lucky accident in science, or does preparation create its own luck? On the afternoon of August 15th, Matthew was exploring near the main excavation site. He was following his dog, Tao, a ridgeback, across the rough terrain. He tripped, he stumbled, he looked down at the rock his boot had caught against. And embedded in that rock, half visible in the red breccia, was a curve of bone. Matthew picked up the rock, about the size of a large grapefruit. He carried it back to his father. His initial interpretation was practical, almost boring. Maybe it was an antelope, maybe a tortoise. Lee Berger took the rock. He pulled a magnifying loupe from his vest pocket. He looked. And then, reportedly in a voice his son had never heard before, he said, "This is a hominin, Matthew. This is a very, very old person." Now, I want to pause right here on the exact forensic detail of what Lee Berger was looking at, because it matters to everything that follows. The bone embedded in that rock was a clavicle, a collarbone. Why does that matter? Because the clavicle is, in a very specific anatomical sense, a diagnostic bone. Its shape, the particular S-curve, the precise proportions of its two ends, tells you an enormous amount about how an animal moves its arms, whether it swings through trees, whether it reaches overhead, whether it uses its hands in ways that are recognizably human.
And the arms were very long, but the hands were more human-like.
How tall?
Maybe 1.3 meters, very small bodied. The legs were elongated a little bit. The pelvis was like ours, but the feet were bizarre, with a heel like a chimpanzee and a midfoot that was more like a human. No one had ever seen anything like it. Walking on two legs, definitely somewhere in our family tree.
Lee Berger had spent decades studying such bones, and what he saw in that first moment, looking through a loop at a rock his 9-year-old son had tripped over, was a shape that did not belong to any antelope, did not belong to any known predator, did not belong to any animal whose remains littered this landscape. It was curved the way a hominin clavicle is curved, familiar, in the most disorienting possible way. And his 9-year-old son was standing next to him asking, "Dad, are we going to be in trouble for picking it up?" That question, that particular perfect 9-year-old question, of the entire weight of 2 million years of human prehistory pressing down on this moment. And a child's first instinct is to wonder if they broke a rule. Lee Berger reportedly laughed, and then he said, "No, Matt, I think everything just changed." But here is what the popular story almost always leaves out. Lee Berger did not announce the discovery, not that day, not for another 20 months. And that silence is where this story gets genuinely complicated. August 2008 to April 2010. 20 months. During those 20 months, Berger's team returned to Malapa repeatedly. They excavated carefully, painstakingly, working around the breccia, the calcified sediment that encased these bones like concrete, the slow, brutal, precise work of chipping away at ancient rock without destroying what's inside it. And they found more, much more. 2 partial skeletons eventually emerged, a juvenile male estimated to have died between 9 and 13 years of age, and an adult female likely in her 20s or 30s. But here's mystery number 3, and this one I want you to genuinely wrestle with, because the evidence is ambiguous enough that serious credentialed scientists still disagree. Why were they together? 2 hominins, a juvenile and an adult female, possibly mother and son. though genetic analysis has never confirmed this, dying in the same location, preserved in the same geological deposit. The dating via uranium lead analysis and paleomagnetic studies I published in the journal Science in 2010 placed them within a geological window of just weeks of each other. Weeks. In 1.98 million years of geological time, they died within weeks of each other. April 8th, 2010. Two papers appeared simultaneously in Science magazine, one of the most prestigious peer-reviewed journals in the world. The world met Australopithecus Sediba, from the Sotho word for natural spring. The juvenile was named Karabo, meaning the answer, and the scientific community did exactly what it was designed to do. It erupted, not in celebration, in argument. And this is where our investigation must slow down, because the content of that argument is not a distraction from the story. It is the story. The fossil itself is a puzzle box. And what is inside that puzzle box forces every question we have ever asked about what it means to be human. Let me describe the anatomy to you as precisely as I can, because precision is everything here. Australopithecus sediba had hands that were remarkably modern looking. The proportions of the fingers, the shape of the thumb, they suggested a capacity for precision grip, the kind of fine motor control that lets you make a tool, thread a needle, pick up something very small with great care. These are human hands in the most functional sense of the word. It had a brain that was small, roughly 420 to 450 cubic centimeters, chimpanzee-sized, essentially. The modern human brain averages about 1,350 cubic centimeters, and this is the detail that matters most. The shape of the brain appeared from endocranial casts to show early signs of reorganization in the frontal lobe. Now, here is the central mystery of the entire fossil. How do you evolve different body parts at different speeds? This is what scientists call mosaic evolution. And Sediba is the most dramatic example of it in the entire hominin fossil record. Different parts of the body evolving toward Homo, toward us, while other parts lag behind or evolve along entirely different trajectories. Think about what this means. Really think about it. We tend to imagine evolution as a kind of progressive software upgrade, a patch that updates every system simultaneously. But what Sediba suggests is that evolution is far messier, far more experimental than that. It is possible for an organism to have human-like hands and ape-like feet, human-like pelvis and chimp-sized brain, modern grip, ancient face. It is possible to be partly human in a way that is not simply an intermediate stage between two clean categories, but a genuinely distinct experiment, a particular solution to a particular set of evolutionary pressures, a Frankenstein of evolution. And this is where the scientific argument got genuinely fierce. The central question, the one that generated the most heat, was deceptively simple to state and extraordinarily difficult to answer. Is Australopithecus sediba our ancestor, or is it a cousin? The distinction matters enormously. If Sediba is a direct ancestor, if it or something very like it gave rise to Homo erectus and ultimately to us, then this discovery fundamentally rewrites the story of human origins. It suggests our lineage passed through South Africa, not East Africa, at a critical juncture. It changes where we look for fossils. It changes how we understand the sequence of anatomical changes that produce the human body. But if Sediba is a cousin, an evolutionary experiment that ran parallel to our lineage without contributing to it, then it is still deeply fascinating, still scientifically important, but It is not the answer. It is perhaps a reminder that evolution generates more experiments than survivors. Now, this is the moment in the story where I have to be completely honest with you. We do not know which interpretation is correct. Not definitively, not yet. The timeline creates a serious problem for the direct ancestor hypothesis. The earliest members of Homo, the genus that includes us, appear in the fossil record at approximately 2.3 to 2.4 million years ago in East Africa. Sediba dates to approximately 1.977 million years ago in South Africa. If Sediba gave rise to Homo, the math becomes extremely complicated. You would need an ancestor of Sediba, something even older, currently unknown, to have been in South Africa earlier than 2.4 million years ago, made its way to East Africa, given rise to the first Homo, and then had descendants persist in South Africa until 1.977 million years ago. It is not impossible. The fossil record has enormous gaps. Absence of evidence is not evidence of absence. But the timeline problem is real. And the scientists who raised it, including some formidable names in the field, were not wrong to raise it. The counterargument from Berger's team was this: the anatomical similarities between Sediba and early Homo are too specific, too numerous, too precise to be coincidental. When two organisms share not just one or two features, but an entire constellation of derived traits, the hand anatomy, the pelvic shape, the brain reorganization, the most logical explanation is shared ancestry, not convergent evolution. Here is where I want you to become a detective. Ask yourself, is it more likely that two completely separate evolutionary lineages, separated by geography and time, independently evolved the same precise configuration of human-like hands, human-like pelvis, and reorganized frontal lobe? Or is it more likely that we simply haven't found the fossils yet that connect the dots? Both possibilities are scientifically defensible. Both have serious advocates. And the honest answer is that the fossils required to settle this debate may still be sitting in a cave somewhere, South Africa or East Africa, are waiting for the next person willing to look. But here's where it gets really interesting, because there is a third mystery I have been deliberately holding back from you. And this one changes everything. Early in the examination of the Malapa fossils, researchers made an extraordinary claim. They found evidence of soft tissue preservation. Let that land for a moment. Not bones, not teeth, not the mineral replaced shadows of ancient anatomy, but actual organic material, remnants of the flesh, the biological substance of creatures who lived and breathed and searched for water nearly 2 million years ago. The claim was handled carefully in the scientific literature. Not skin exactly, but organic matter in the breccia surrounding the fossils. Substances that, if genuinely biological in origin, would represent an unprecedented window into the physical reality of our ancient relatives. Now apply your detective instincts. The claim remains unresolved. Subsequent analysis has been cautious. The geological context of the Malapa site, with its complex chemistry of calcification and mineral infiltration, makes it genuinely difficult to distinguish ancient organic matter from more recent biological contamination, or from non-biological mineral compounds that can mimic organic signatures. So what does that uncertainty actually mean? It means the most tantalizing possibility in the history of paleoanthropology actually touching the biology of Australopithecus sediba, understanding not just its bones, but its body, what remains exactly that, a possibility. A question mark sitting at the intersection of extraordinary hope and rigorous scientific doubt. And here is why I find that uncertainty more interesting than a definitive answer would be. The very fact that the question could be asked, that the preservation at Malapa was extraordinary enough to raise the possibility of soft tissue evidence tells us something crucial about the site itself. When those two individuals fell into that shaft and were rapidly encased in calcifying sediment, their bodies were sealed from the destructive processes that reduce most organisms to nothing within decades. They were archived, preserved, held in geological suspension for 1.977 million years. What Matthew Berger found was not just a fossil, it was a time capsule with an unknown contents list, and we are still opening it. So we're about halfway through this story, and I want to pause for just a moment. If this documentary is giving you that feeling, that particular pull of wanting to know more, wanting to understand the world a little more deeply than you did 30 minutes ago, then please take 5 seconds right now and hit the like button. I know that sounds small, but on YouTube, every like tells the algorithm that this kind of content matters, that stories like Matthew Berger's deserve to be found, that history and science and the honest pursuit of truth are worth more than a 15-second clip. And if you have a friend who geeks out over human origins, ancient discoveries, or scientific mysteries, send this video to them right now, honestly. They will thank you for it. All right, back to the story. And because what happens next might be the most quietly radical thing Lee Berger ever did. Most people stop the story here, at the fossil, at the fight, at the debate. But what happens next is, in many ways, just as significant. In 2010, simultaneous with the publication in Science, Lee Berger made a decision that was, by the standards of his field, genuinely radical. He released the 3-dimensional scan data of the Malapa fossils freely, publicly. Anyone in the world with an internet connection could download, examine, and analyze the anatomy of Australopithecus sediba for free. Matthew Berger grew up. And this seems like an obvious thing to say, but it carries weight in the context of this investigation. The 9-year-old who found a collarbone in red South African dust became a teenager, then a young adult, carrying a particular kind of identity that almost no one in history has ever had to navigate. He is the boy who found humanity's ancestor, or perhaps humanity's cousin. We're still working on that. In later interviews, Matthew has spoken about this with a thoughtfulness that belies the lightness of his public image. He has described feeling, as he grew older, the difference between being famous for something and being responsible for something. Matthew did not find a fossil. He found, in some profound sense, himself. Now, remember that question I asked at the very beginning and left unanswered? Why did it take satellite technology to find what human eyes had missed for 100 years? What were people looking for that made them blind to what was actually there? The answer is not flattering to the scientific establishment. For most of the 20th century, the search for hominin fossils in the cradle of humankind was conducted within a very specific framework of assumptions. You looked in known cave systems. You looked in sites that had already proven productive. You looked in the places where your predecessors had looked, following the tracks of the Darwins, the Leakeys, the Brooms, the Darts, the great names of a field built on a foundation of expeditionary authority. Lee Berger, armed with Google Earth and a career-driven desperation to look differently, did not have that blindness, or rather, he had chosen to set it aside. He was looking at the landscape not as an archaeologist's map of known sites, but as a geological image of unexamined terrain. He found 600 caves the field had collectively missed. The lesson here is not simply technological, it is epistemological. What we find is shaped by what we allow ourselves to look for. This principle echoes through the scientific arguments about Sediba itself. The field had assumed human evolution was a largely East African story, that anatomical changes followed a predictable sequence, that the path from Australopithecus to Homo was relatively linear. Sediba challenged every one of those assumptions simultaneously. And the resistance, the skepticism, the alternative interpretations, the critics who questioned the dating and the phylogenetic placement, that resistance is not simply professional jealousy or academic territorialism, although there was surely some of that. It is the entirely predictable and indeed necessary response of a scientific framework encountering evidence that does not fit its expectations. Good science does not smooth over those conflicts. Good science sits in the discomfort of them until the evidence compels resolution. We are still sitting in that discomfort, and that is entirely appropriate. I promised you at the very beginning of this investigation that I would be honest about what remains unknown. It is time to honor that promise. Here is what we know with high confidence. In August 2008, at the Malapa site in the Cradle of Humankind, Matthew Berger found a hominin fossil that proved to be part of two remarkably complete skeletons dating to approximately 1.977 million years ago. The species was formally described as Australopithecus sediba and published in Science magazine in April 2010. As documented by Lee Berger and his colleagues at the University of the Witwatersrand's Evolutionary Studies Institute. Was the thing Matthew Berger found actually our ancestor, or did it die so that we could live? I told you those were not the same question. Let me explain why. If Sediba is our ancestor, then its particular combination of anatomy, those modern hands, that reorganizing brain, that transitional pelvis, is the configuration from which we descended. We are the continuation of its experiment. But if Sediba is a cousin, something even more extraordinary may be true. It may have died not individually, but as a lineage, precisely because it was competing with our actual ancestors. Because the first members of Homo were, in some specific environmental niche, marginally better adapted to the pressures of that ancient African world. The extinction of Sediba's lineage may have been, in an evolutionary sense, the clearing of space that allowed our direct ancestors to expand. In that interpretation, Sediba did not die for us. Evolution has no purpose, no intention, no teleology. But Sediba may have died instead of us. And in dying as a lineage, it left us these two individuals in a vertical shaft, preserved in calcified rock, to be found 2 million years later by a 9-year-old chasing his dog. There is no clean resolution to this mystery, but there is something better than a clean resolution. There is a continuing investigation. The Malapa site is still being excavated. More fossil material is expected. Ancient DNA recovery methods are improving rapidly and may eventually allow us to understand Sediba's relationship to other hominins at a genetic level, not merely an anatomical one. The three-dimensional scan data that Lee Berger released publicly has been analyzed by researchers around the world. Papers continue to appear. The debate deepens, refines, evolves. The bones are still speaking. We are still learning to listen. I want to end where I began. Two numbers, 1,977,009. In the gap between those numbers, the entire arc of the human experiment is compressed. A creature with our hands, but not yet our brain, dying in darkness, preserved by geological chance, discovered by a child with the particular kind of seeing that comes from being taught to look. The hand that Karabo used, that precise modern tool-capable hand, reached in some biological sense across 1.977 million years and landed in the hand of a boy. And the boy picked it up. That is not metaphor. That is the literal, documented, scientifically verified sequence of events, verified by the University of the Witwatersrand, published in Science, confirmed by uranium lead dating and paleomagnetic analysis. And in that literal sequence is something that defies easy categorization. Not supernatural, not sentimental, but genuinely and irreducibly human. We are the species that finds our ancestors, that names them, studies them, argues about them, releases three-dimensional scans of them for anyone in the world to examine. We are the species that gives a 2-million-year-old juvenile the name Karabo, the answer, even while we are still arguing about the question. We are the species that lets a 9-year-old stumble rewrite the human family tree. And we are the species that is still, after all of this, genuinely unsure what we are, which is, if you think about it, the most human thing of all. The investigation continues. Somewhere in the cradle of humankind, there are almost certainly more caves, more time capsules, more questions pressed into rock, waiting for the next person willing to look where everyone else has already agreed there is nothing left to find. And maybe that next person is someone watching a documentary exactly like this one. Maybe it is you. If this story moved you, if it made you sit up straighter, lean in a little closer, or say out loud, how is this real? Then this channel has more waiting for you. We go deep on the discoveries, the people, and the moments that science almost missed and history nearly forgot. Subscribe if you haven't already. But it genuinely helps this channel grow and keeps these stories in front of the people who need to hear them. Drop a comment below and tell me, do you think Australopithecus Sediba was our direct ancestor or a cousin that evolution left behind? I read every single response, and some of your answers will shape the next documentary we make. Thank you for spending this time with Karabo, with Matthew, with the quiet 2-million-year-old mystery sitting in the red rock of South Africa. The investigation continues. We will see you in the next one.